Voyager to turn its camera back towards Earth, and it's what basically amounts to Earth's first ever selfie. And that picture was taken, and there was this pale blue dot.
Neil deGrasse Tyson is a well-known figure in the scientific world, having begun his journey in academia when he was accepted to study physics at Harvard University. As an astrophysicist, author, and science communicator, Tyson has long championed the cause of increasing NASA's budget, arguing that the agency is underfunded for the crucial tasks it needs to accomplish. Beyond advocating for greater funding for NASA, Tyson has also been vocal about the mysteries of the universe, particularly the events that unfolded long before our existence. He maintains that there is still so much we don't know about our universe, and that it's important to continue exploring it. This is why Tyson's curiosity was sparked when Voyager 1 recently detected 775 previously unknown objects passing through space. Mother Earth is an extraordinary planet, brimming with awe-inspiring characteristics. Yet, in the grand scheme of the universe, it is but a tiny speck. Philosophers have recognized this truth for centuries, but it wasn't until the 1970s that NASA scientists provided a way to demonstrate it. This groundbreaking invention, however, might never have come to be without the rare alignment of the stars, specifically the 4 largest planets in our solar system. This planetary alignment had gone largely unnoticed until Gary Flandreau, a PhD student at the California Institute of Technology, brought it to light. Flandreau, who was working part-time at NASA's Jet Propulsion Laboratory, was mapping the orbital trajectories of the giant planets, Jupiter, Saturn, Uranus, and Neptune. During his work, he made an astonishing discovery. He realized that in the late 1970s and early 1980s, all 4 planets would align in a rare celestial arrangement, forming a long arc with Earth. This revelation thrilled NASA's leadership, as Flandreau had been tasked with finding the most efficient way to send a space probe to Jupiter and the other giant planets. This rare alignment meant that a spacecraft could gain a significant speed boost from the gravitational pull of each giant planet it passed. It would be as if an invisible cord was pulling it, snapping just before release and sending the probe on its journey. According to Flandreau's calculations, the repeated gravity assists from the planets could reduce the travel time between Earth and Neptune from 30 years to just 12. However, there was a catch to the excitement surrounding this discovery. The alignment occurred only once every 176 years. As a result, to catch the planets during the alignment, a spacecraft would need to be launched in the mid-1970s. This information was escalated within NASA, and the space agency decided to capitalize on this rare opportunity by developing 2 spacecraft. These twin spacecraft, Voyager 1 and Voyager 2, were identical in every detail. They were launched just 15 days apart in the summer of 1977, with Voyager 1 specifically launching on September 15, 1977. The space probe is a part of the Voyager space program, tasked with the mission of exploring the solar system and interstellar space for our benefit. Voyager 1 has been in operation for almost 5 decades and has been communicating with the scientific community through the NASA Deep Space Network. It receives routine commands and transmits the data back to Earth. We are able to monitor the real-time distance and velocity data thanks to NASA and its Jet Propulsion Laboratory. As of August 2023, the space probe was situated 24 billion kilometers away from the Earth. This makes it the most distant man-made object away from the Earth. The Jet Propulsion Laboratory executed the design and construction of Voyager 1. The probe left our planet from Launch Complex 41 at the Cape Canaveral Air Force Station aboard a Titan IIIe launch vehicle. Voyager 1 launched just 2 weeks after its twin, Voyager 2, with the goal of exploring the outer planetary heliosphere and the interstellar medium. NASA was eager to understand what lies between the stars, and the Voyager mission was designed to bring this vision to life. From the outset, NASA scientists determined that the spacecraft would need to conduct flybys of Jupiter, Saturn, and Saturn's largest moon, Titan. Although Voyager 1 was launched later than Voyager 2, it reached Jupiter first. It went on to study the 2 gas giants, examining their weather, magnetic fields, and rings. Thanks to Voyager 1, we gained detailed images of the moons of both Jupiter and Saturn. As previously mentioned, the Voyager mission didn't limit itself to studying Jupiter and Saturn. The spacecraft ventured further, exploring the outer regions and boundaries of the heliosphere. It also expanded its mission to investigate the interstellar medium. On August 25, 2012, Voyager 1 made history by becoming the first spacecraft to cross the heliopause and enter interstellar space. 2 years later, in 2014, confirmation came that Voyager 1 had indeed reached this new frontier. The spacecraft encountered a third wave of coronal mass ejections from the Sun, continuing until December 15 of that year. Voyager 1 also provided humanity with the first family portrait of the solar system, captured from beyond its edges. It also captured the iconic pale blue dot image of Earth. After leaving the heliosphere, Voyager 1 set its course toward interstellar space, marking the beginning of its journey between the stars. Despite this, the spacecraft's instruments continued to monitor the solar system. Although Voyager's mission was supposed to have ended years ago, NASA's engineering team worked their magic, extending the spacecraft's mission until 2025. By then, it is anticipated that the spacecraft will no longer have enough power to operate its scientific instruments. This incredible achievement was made possible when the team tested the space probe's trajectory correction maneuver thrusters in late 2017, an event that marked the first time these thrusters had been used since 1980. The decision to fire the thrusters succeeded in extending the mission's lifespan by 2 to 3 years. One look at the gains achieved by Voyager 1 in the past 4 decades, and it would be hard to believe that the craft's launch almost failed in the summer of 1977. This was because a part of the launch vehicle had shut down prematurely, and this caused 1,200 pounds of propellant to become unburned. Nevertheless, Voyager 1 is currently traveling at about 523 million kilometers per year. This is about 1 light-year per 18,000 years. Speaking of traveling, Voyager 1's highlight speed would have been a waste of time. If the spacecraft hadn't been outfitted with the proper instruments, it wouldn't have been able to operate as effectively. However, it is equipped with 16 hydrazine thrusters, gyroscopes for 3-axis stabilization, and referencing instruments that ensure the craft's radio antenna stays pointed at Earth. These components work together as part of the attitude and articulation control subsystem. The Voyager spacecraft also has 8 backup thrusters and includes 11 additional scientific instruments designed to study celestial bodies as it journeys through space. These scientific instruments are the Imaging Science System, Radio Science System, Infrared Interferometer Spectrometer, Ultraviolet Spectrometer, Triaxial Fluxgate Magnetometer, and Plasma Spectrometer. The other 5 include the Low-Energy Charged Particle Instrument, Cosmic Ray System, Planetary Radio Astronomy, Photopolarimeter, and Plasma Wave Subsystem. Some of these instruments are currently active, while others are either disabled or malfunctioning. NASA engineers designed the radio communication system of the Voyager to be used up to and beyond the limits of the solar system. The communication system consists of a 3.7-meter diameter high-gain antenna to send and receive radio waves via the 3 deep space network stations on Earth. When Voyager 1 is unable to communicate directly with Earth, it makes use of its digital tape recorder. The DTR can record about 67 megabytes of data for transmission at a later time. As of 2023, signals from the Voyager take over 22 hours to reach planet Earth. The Voyager spacecraft was equipped with advanced cameras for capturing images of planets, their moons, and other celestial objects from afar. However, these cameras do not operate automatically for visible light. Instead, their functioning is managed by an imaging parameter table stored in one of the spacecraft's onboard digital computers. NASA has since moved away from this approach, as later space probes from the 1990s featured fully autonomous cameras. Voyager 1 uses a computer command system to control its cameras. The CCS includes pre-programmed functions for tasks such as command decoding, fault detection, antenna pointing, and spacecraft sequencing. This system is an upgrade from the one used in the Viking orbiters of the 1970s. It's been almost 5 decades since Voyager 1 and its twin, Voyager 2, were launched into space to study the cosmos and bring exciting discoveries to our knowledge. The spacecraft's instruments have been operating consistently over the years, transmitting data back to our planet. One would have expected that this spacecraft, which is located over 14.1 billion miles away from Earth, would have begun to fail. But this is far from the case, as the Voyager's computer systems continue to work effectively, capturing and transmitting data back to NASA scientists. Thanks to the ingenuity of NASA engineers, Voyager 1 has exceeded expectations in its interstellar mission. Through careful power management and the use of backup computer subsystems, NASA scientists have been able to keep the spacecraft operational. Regardless, scientists remain focused on understanding the 775 objects Voyager 1 discovered, and we hope future advancements will help unravel this mystery.